much. So today we are starting with t-test. I'll be taking you on t-test, ANOVA, and binary logistic regression using SPSS. But tonight we are just going to cover t-test and ANOVA, analysis of variance. And the content I have before me, under t-test, we are going to be comparing means, the first one. The next one, we're going to be looking at one sample t-test. I'm going to look at independent sample t-tests, paired sample t-test, one-way ANOVA. All of these things I just listed, we are going to look at them tonight. And by the time I will come in next, probably next 2 days, we'll be looking at binary logistic regression with SPSS. And I believe we are going to have a very good time together. Can we still see my screen?
I can't see your screen. Yes. I can't see your screen.
Hello, am I talking to somebody?
Yeah, I can see it.
You are talking to us, but I can't see your screen.
I think some people are still.
It's probably going to be network because I can see a screen.
Probably I should unshare and share again. Can we still see my screen?
Yes, one is waiting.
Yes, sir.
Yes.
Are we seeing my screen?
I can. Yes, I can see your screen, sir. But you know what? Maybe you should share the entire screen.
But what?
Share the entire screen, sir.
Don't share by window. The entire screen. Can you see the? I'm sharing my entire screen.
Okay, sir.
Can you see my SPSS window? Can you see my SPSS window?
Yes, we can see.
Yes, sir. You can see it, sir.
Can we continue now?
Yes.
Please, am I the only one?
It seems that
I think someone is complaining not seeing the screen.
I can see it now.
Thank you very much. Thank you very much. So the data set we have before us tonight, and we are going to still use it for our binary logistic regression, is was extracted from the NGHS data of 2018, Nigerian the survey that the National Bureau of Statistics conducted in 2018, and it has some variables here such as age, the anemia level, the anemia status of our respondents, the gender of our respondents, the educational attainments of our respondents, their body mass index, their weight, their hemoglobin level, the partner's age, okay, and their place of residence. Now, one very good thing I want us to do before we continue is to have the right configuration for our data set, right? If we are doing anything in SPSS, we have to specify the correct scale of measurement that we are of the variable that we are dealing with. And quickly, the age here is measured on a continuous scale, and that is why it is continuous here. The anemia level, it has 4 levels. We have severe, moderate, mild, and not anemic. Okay, and it is a categorical data, definitely. The gender is a categorical data, male and female. The educational attainment, body mass index, and so on like that. Okay, so they are already there. If we need this data set, you can request for it for your own practice after the class. So the very first thing we'll be doing tonight is comparing means. We're going to be comparing means. Now, when we are comparing means, it's not actually a test. Okay, means comparison is not actually a test. What I have here in my slide is just a mistake. It's not a test. Now, It helps us to summarize and compare differences in descriptive statistics across one or more factors or categorical variable. Okay. Now, for us to be able to compare means, it's we have to have a dependent list and a categorical variable, or more than one categorical variable, or more than one dependent list. Now, the important thing here is that our dependent variable here must be measured on a continuous scale. Okay, it must be measured on a continuous scale. If it is measured on a non-continuous scale, maybe it's categorical, yes, SPSS will give us an output, but any inference we are going to be making on that output is definitely not going to be correct. For example, I'm telling SPSS to give me the mean of gender, which is not a continuous variable. Okay, because I've coded my gender to be 1 and 2 or 1 and zeros, SPSS will give me the mean, of course. But if I make any inference on that mean value that I have, I'll be saying rubbish, right? That is why we must have a our dependent list to be a continuous variable. Now, let's compare means. I'm coming to my SPSS back. Let's try to compare our means. Can we still see my screen?
Yes,
Can
yes,
we?
yes. We can see.
Yes. Okay. Okay. Thank you very much. Now, the very first thing here is for us to compare means, and I click on analyze, compare means, and I go to means. Now, the dialog box that pops up, remember, we need a continuous variable as our dependent list, right? Now, what this does, what this particular box, this particular analysis does is, for example, in a classroom of male and female, they have their ages, age 10, 12, 11, 6, and they are male and female. Now, you can actually, with this very little analysis of discrete statistics, we can actually know the mean age of male and the mean age of females. Okay, now that is just briefly what this does for us. Now, in this place, let's pick the hemoglobin level of our respondents, and let's use their gender, okay, the sex, as our independent list. Now here, if you check here, you're going to be seeing layer 1 of 1. We are still coming to that one. You see next, we are coming to that one. Now clicking on options, options will give us different statistics that we may like to compute. Okay, by default, we have mean, number of cases, and standard deviation. I'm not going to touch anything. Okay, but if you feel like you need the maximum, you need the minimum, you need the range, you need anything, you can just click it and throw it inside the box. Okay. Now the style, you don't need to do anything here. Bootstrap, nothing. Okay. Now the output is here, and what this is actually giving us the mean hemoglobin level of male is 114.6. Okay, and the number of male that we have is 150. While the mean hemoglobin level of female respondents is 118.54, right? This is just descriptive statistics, but it has helped us to categorize them, okay, very easily, right? Now, let's go back to analyze. Compare means. Now, let's try to layer it. Let's try to add a layer, okay? Before, we used just layer 1 of 1. Let's try to add a layer, and let's use place of residence as layer 2, right? And let's see what happens. Okay. Now, when we layer it, we are having this, Now, what this implies is that for male respondents that reside in urban areas, okay, the mean hemoglobin level is this value. I hope we are seeing my screen. I don't want to mention the value because I'm trying to speed up. Now, for male respondents that resides in rural areas, the mean hemoglobin level, their mean hemoglobin level is this value highlighted in black. Okay. As well, for female respondents that resides in urban, their mean hemoglobin level is this guy. Okay. And for female respondents that resides in rural area, their mean hemoglobin level is this. Okay, that's just what mean comparison does for us. It helps us to compare the means of a continuous variable across different levels of categorical variables, right? Now, I'm moving forward to the next thing here, which is where we are going to be starting our hypothesis testing. Okay, now this class is not going to be different from our normal statistics class. Yes, it's not different. The only difference that will be there is that we are not going to be computing with our pen, we'll be computing with the software. Now, for the one sample t-test, please, am I still communicating?
Yeah, you are communicating, sir. I don't.
All right, thank you. Now, for the one sample t-test, now one sample t-test, if we are using one sample t-test, it's time for us to test the mean value of a target variable against an hypothesized value. Now, for example, we are told that the average age of applicants in University of Ilorin every year, we are told that their average age is 20 years old, for example. Now, in 2023, we now collected a sample of maybe 100 applicants, and we want to test if their average age is different, okay, is different from the hypothesized, the general mean value of 20 years old. Okay, now this is what this particular thing is what one sample t-test will do for us. Now let's go back to our SPSS, and I will try to, as much as possible, to be giving the interpretation, because I believe this is going to help us in our project writing. So I won't just be running the analysis and blue. No. So compare means we're moving to the next one, which is one sample t-test. All right. Now, here, remember, your statement of hypothesis is that the mean you are comparing is equal to the hypothesized mean. I'm talking about the hypothesis here, right? The mean you are comparing is equal to the hypothesized mean versus your H1 now. The mean is different. Now, let's come to our SPSS back. Let's come back to our SPSS. Okay. Now, let's look at, before we, okay, let's look at hemoglobin level. Let's use the hemoglobin level again. And then let's use 84 as the hypothesized hemoglobin level. We entered into an hospital and we're told that the hemoglobin level of the average hemoglobin level of patients that have been tested in that very hospital for the past 5 years is 84. Okay. And we now collected our own new sample and we want to check if the hemoglobin level, the mean hemoglobin level of those former people is statistically different from the mean hemoglobin level of those ones that we just collected, right? So now we are using the test value 84 and we have hemoglobin level. Let's look at options. Do we need to check anything here? No, we continue. No need for bootstrapping, then we click OK. Now, the very first table that comes here is the descriptive statistics. It just, and this guy is the number of samples 163. The mean hemoglobin level of all the respondents is this very figure here, the standard deviation and the standard error. Now, coming to the main test. Coming to the main test now. Now, for we are going to be using p-values to make our decision, because it is quite easier to use p-value. We are going to be using t. We are just going to be computing, checking our t-value from our table. But since the software has computed the p-value for us, we are going to be using p-value for our decision. Now, before we make our decision, the main difference here is the difference between the hypothesized mean, which is this guy, and the original mean of our sample, which is this guy. That's the main difference, which is this. Now, the confidence interval for the mean difference is what we have here, okay? And it shows that we are 95% confidence that the difference between the mean is as low as 28.76 and it is as high as 33.07. Okay. Now, coming to our testing, we said H naught mean equals to 84. Now, we reject H naught if p-value is less than alpha, and our alpha by default here is 5%. That's 0.05. Now, since this p-value is less than alpha, it is this particular p-value is 0.001, it is less than alpha. That means we reject H naught. Hence, we conclude that the mean hemoglobin level of our sample, of this sample taken, is different from 84. Right? I think we are good. Can I continue? Am I communicating? Can we continue to the next thing?
Yes, sir, you are communicating, sir.
All right. Thank you very much. So that is just what one sample t-test does for us. It helps us to test if the mean of a particular set of samples is statistically different from an hypothesized mean. And we've just seen how we did that now. Now, the next thing on my slide is the independent sample t-test. The independent sample t-test. Now, the independent sample t-test is done. I'm reading this guy now.
Sir Bidex, before you move on, please, I have a question.
All right.
Before you move on, I have a question, please. I did not get how you got that table, the ANOVA table, how you were able to get that table. Please, can you come again with that process? Thank you.
Okay. Thank you for the question. Now, I said we want to test if the mean hemoglobin level of our respondent is different from 84, right? We come to analyze, right? We go to compare means, and the appropriate test for our problem now is the one sample t-test. We click on one sample t-test. I'm resetting this guy. By default, this is what you have. So your test variable, the variable that you want to test, you send it inside. No, I used the hemoglobin level. You send it inside the box. And now the hypothesized mean that you want to test it against, you put it in the test value. And we used 84. And that is all. Then, okay. Shibomi, did you get that now?
Yes, thank you very much.
You're welcome. So we continue. Now, on the independent sample t-test, we said this test is done when you want to determine if the mean value on a given target variable for one group differs from the main value on the target variable from a different group. Let me explain. Now, this test is only valid when you have, now, when we go to our SPSS test, SPSS we understand very well. Now, okay, for the first box, the test variable is entered here, and it was measured on a continuous scale, right? Now, this test, this independent sample t-test, is just almost the same thing when, like, the time we're comparing means. But when we're comparing means, we only compared the means, okay? We didn't have any test. No test was carried out. No hypothesis was tested. We only compared means. It was more or less like a descriptive statistics, right? But now, the independent sample t-test will allow us to test if there is difference between, okay, I used the example of a classroom where we have boys and girls, right? And they have age, they have their ages recorded. Now, this particular, when we did the first one, we only checked, when we did the compare means, we only compared the means of boys, the mean age of boys and the mean age of girls. Now, in this place, we are going to be testing if there is difference between the mean age of boys and the mean age of girls. Okay, now for you to do, the grouping variables must have at least two categories. I mean, this particular box, this particular area of the box, it must have at least two categories. It can have more than two categories, but the only thing you can use here is, the only number of categories you can use here is just two categories. Let's go to our SPSS. We are analyzing, comparing means, and we are doing the independent samples t-test. Okay, now here let's look at something else. Let's look at the anemia level. And okay, now let's look at the body mass index as our test variable. We said the test variable must be measured on a continuous scale, right? Now, the grouping variable, let's look at okay, let's look at the place of residence. Now, immediately you send in the grouping variable, you will see question mark, and the button for you to define your group becomes active. Let me send it back. Before I send in the grouping variable, this button for me to define my group is not active. When immediately I send it in, the button becomes active. Now, but we must do one thing. For us to define our grouping variable, we can see when we click on define groups, we have only group 1 and group 2. There is no column for group 3 or 4. It can only take 2 groups. Now, what we now put here are the groups of our grouping variables. What do I mean? The place of residence. How did I define the values of my place of residence? Is it rural and urban? Is it Lagos and Abuja? Right? They are the things that I'll put here. But one thing we have to be careful of is that if I used capital letter to define my values in my data set, I must use capital letter in my groups, else it will not run, right? So now, let's check how we defined our place of residence so that we are going to know how we are going to define our groups. Now, for our place of residence in my data set, we have urban and rural. Let's come to our data. Place of residence. Look at them. Urban and rural. Arrow starting with capital letter, and urban starting with capital letter as well. So now let's go back to analyze. Compare means independent samples t-test. we are comparing their body mass index, and we are using the place of residence as. Now, the first group is the rural, and the second group is urban. Continue. We don't need to check any other thing. Okay, fine. The independent sample table is not produced. Can we see my output?
Yes, we can.
Yes, very good. I deliberately allowed this mistake to come up so that we'll be able to watch out whenever we are doing something like this on SPSS. The independent samples table is not produced, and the original table, nothing was computed. Now, the reason is because if you go back to our data view, our variable view, the reason is because this particular guy, number one, is not supposed to be measured on a string. It's supposed to be measured on numeric data type, right? Now, the reason why it will be measured on the numeric data type is because we have defined the values here that to be 1 equals to urban and 2 equals to rural, right? Okay. Now, it is numeric. The way as I'm toggling my this arrow, this particular guy, we can see that it is changing from rural to 2 and 1. So let's go back to analyze. Compare means independent sample t-test. So this particular guy now, I will redefine this thing. Now, group 1 to be 1, group 2 to be 2. I'm no longer going to be using urban and rural because I've defined it now to be numeric, and I'm now going to be using the numerical values that I defined. Okay, so continue and okay. Now we have our independent samples t-test produced. Now the very first table here is the descriptive statistics, and there's nothing we can all understand this one. The number of just the number main as navigation. Now the main thing here is the output for our independent sample test. Now this output actually brings out three different tests for us. Okay, okay, let me say two, let me not say three, two, right? Now the first one is Leven's test, and the second output is the main t-test, right? This is the Leven's test, and this is the main t-test. Now the reason why SPSS gave us the output for Leven's test is because one of the major assumptions that shouldn't be violated when you are running this test is the homogeneity of variances. Sigma square 1 must be equal to sigma square 2. The variances must be equal, right, for the two groups. So if the variances are not equal, you don't use the independence, you don't use the t-test again, you use another test. Okay, and that's why I said this table gave us three tests. The first one is a Leven's test for equality of variance. The second test is the t-test for equality of means. Now this t-test for equality of means, it has the normal t-test, normal independent sample t-test, which is the first one here. This first place is the independent sample t-test. While this second place here is the Welch test, WELCH test. Okay, now you start with the Leven's test. Now the hypothesis for Leven's test is that sigma square 1 must be equal to sigma square 2, and the alternative hypothesis is that sigma square 1 is not equal to sigma square 2. Now, the decision is that we reject H naught if p value is less than alpha. I'm talking about Leven's test now. We reject H naught if p value is less than alpha. In this case, our p value is not less than alpha, right? So we do not reject H naught. Are we okay? We do not reject H naught. That means that what? That means the variances are equal, right? Now, if the variances are equal, this is where you check. If the variances are equal, this is where you check your output for the independent sample t-test. You will check it across this place. Let me just highlight the hair. You check it across this particular row. This is the row where you check your output for independent sample t-test if the variances are equal. So for this particular test, the variance is equal. So we check for equality of means in this place. Now, had it been that the variance is not equal, you check for the equality of means in this second row. So now, since our variance is assumed to be equal, we can now make a decision in this place. Now, we now go back to the hypothesis for independent sample t-test. This is the hypothesis. Mu1 equals to mu2 versus mu1 not equal to mu2. Now, reject H naught if p value is less than alpha. In this place, our p value, which is this guy, 0.161, is greater than alpha. So we do not reject H naught. Am I right? My head is already. Am I right? Someone should help me.
Yes, sir.
Okay, very good. So we do not reject H naught, which means that the variances are, the mean are equal. The mean of what now? The mean of, what are we comparing? What are we comparing? What are we comparing? What did we compare? Okay, the mean of the body mass index for people that reside
Body mass
in,
and type of resident.
yes, the mean of the body mass index for people that reside in urban and for people that reside in rural areas are equal. That is just so when you're writing your report for your project, you start by the Leven's test for equality of variances was conducted and the p-value was found to be 0.98, which is greater than alpha. So the variances are equal. So just cook up the English like that, in as much as you understand your output, this very particular table. Can we move on to the next?
Please,
Any question?
please, can you just show me how you did that level test again? Because I was having issues with the screen. Yeah, I can't see your screen before, sir, but please just let me go back sharply.
Yes. Okay. So I will quickly analyze it again. Analyze. Compare means. Independent samples t-test. That is what we want to do. Now, did you get this part, sir? Where we define our group?
I got the part.
Did
I
you get
got
this
this
part?
part. Yes, I got it.
Hello. Okay, I think it's off. Are we hearing me?
Yes, I can hear you. I can hear you.
We can hear you, Sabi
Are we
Dex.
hearing me?
We can hear you,
Yes, I
Sabi Dex.
can.
Okay. All right. So when you just when you just send in this guy and you define your groups, right? Just analyze
Yes.
the 11 steps will come with the output automatically.
Oh, okay.
Yes.
Okay, I get it. I get it now.
The 11 steps will come with the output automatically. Reason being that for you to for you to use the independent samples, reason being that for you to use the okay, now the 11 steps will come out with the output automatically. Reason being that for you to use the independent sample test, you must have equality of variances. So it is the 11 steps that will help us to know if the variance is of the two groups are equal. If the variance of the two groups, variance of the body, if the variance of the body mass index can okay, I think I'm back. Sorry for the interruption. I'm sorry. Can we continue now?
First,
Can we continue now?
Yes, sir, you can continue.
All right, thank you very much. So we are moving to the please, please, you can mute your microphone if you are making noise, please.
Okay. Hello, Bidex. You can unmute yourself, Bidex. Thank you.
Okay. All right. Can we continue now?
Yes,
we
we
hearing
can.
me?
Yes, yes, we
Okay,
can
okay, thank you
continue.
very much. Now we are moving to the paired samples t test. Now the paired samples t test is a very useful test. It is used to check the effect of of applying a treatment on set of observation. Probably, for example, some students had an examination. We have their scores. Now, we now took them through tutorials, okay? And they had the examination again. We now record their scores again. Now, this peer sample test will allow us to know if there's a difference between their score before they had tutorials and after they had tutorials. Hence, it will help us to be able to know if the tutorial is actually effective, if it actually have effect on them. So maybe you want to be paying for the tutorials, maybe it doesn't have effect. I won't have to pay for tutorials again, or maybe it has effect. You can be paying for tutorials. So that's what the paired sample test does. Again, for example, some patients are taking a particular drug before. Now the drug was new component or new stuff was added to the drug. They now started taking it again. They now measured the improvement. Now, the same set of participants that took the first treatment, you give them another treatment. Okay, that is what paired sample studies allow us to do, to be able to measure the effect of whatever manipulation we have had on our variables. Okay, now the hypothesis for this says mu d equals to 0. That is the mean difference of the before and after is 0. That means there's no difference between the before and after. Okay, now the alternative hypothesis says mu d is not equal to 0. That means mean difference is not equal. That means there's a difference between the before and the after. Let's go to our SPSS now. We want to analyze again, comparing means, and we are now in the, okay, I skipped the summary independent samples test because I feel like it is not needed. I can actually show us what we have there. Okay, can we see my screen?
Yes, we can. Yes, we can.
Okay, for the summary, for the t-test computed summary, for example, we have a sample. We have two samples. We have their number of cases. Okay, for the first sample, let's say we have 15. Their mean to be 1.5, 1.4. Their standard deviation to be 0.5. Okay, and the second sample, they are also 15 in numbers. Their mean is 2.3. Their standard deviation is 0.9. Okay, now if you run this particular analysis, it will be able to give us the independent sample t-test. Unlike giving the software a raw data, you have now given the software a summary data. That is just it. Okay, so we are not going to be running that. I'm not going to do that to save our time. So we are moving to compare means paired sample t-test. Now, okay, now let's do something very quickly. This is our data set. And here we have weight. Let us assume that this is the weight of our respondents before they start exercising, before they start daily exercise. Okay, this was their weight. Now, when they now saw a doctor, hello, my weight is too much, I want to reduce it, the doctor now prescribed early morning exercise for them. Now, they now have, after a month, they now computed their weight again, right? Now, we are now going to have a weight after. And let me quickly create another variable just to simulate a new variable for weight after. Now, before I do that, I want to quickly check the minimum. I quickly want to check the descriptive statistics of our weight, so I will know what to do. Weight. The minimum is 423, and the maximum, okay, the maximum is 650. Now, let me create another variable. I want to quickly compute a new variable. Let me name it weight after exercise. Weight after exercise. Now, it is a random number. I want to generate random numbers now. But the random numbers will be generated following a uniform distribution. So, random variable uniform minimum value, let me say 410, and the maximum value now is 600. Close it. Okay. Now let's come back to our data. We now have the new variable that has been created. So let's name it weight after exercise. All right. So now it is measured on its continuous scale. Now let's analyze now. Compare means paired sample t-test. Now, the before, right, is the weight of our respondent. Where is it? This guy. Now, after a month after they start exercising, their weight again, the same set of people. Okay, so we click OK. Now this is the output t-test. Now, the very first table here is the descriptive statistics. Now, the mean weight of our respondents before they started exercise was 435.67. Now, after they started exercising, it was roughly 500, right? Now the correlation, it shows the correlation. This table shows the correlation. Now, between the previous age and their age now, and you can see that there is close to zero correlation, right? Okay. Now, the main test that we are after is the paired sample t-test. Now, we're going to be making our decision with the p-value, which is this. Now, this p-value is very, very close to zero. It is not zero. It is 0.008, 0.00831, right? Now, reject H0 if p-value is less than alpha. What is H0? H0 states that the mean difference is zero. That is, there's no difference between the before and after. Now, since p-value is less than alpha, we are going to be rejecting H0. And therefore, we conclude that there is significant difference between the weight of our respondents and before they started exercising and their weight after they started exercise. Do we understand this part? If I continue.
Please come again, please.
I said the hypothesis for this test is that there is no difference between the mean weights, the null hypothesis, and the alternative hypothesis is that there is difference between the mean weights. Okay. Now, reject H0 if p-value is less than alpha. Now, since this p-value is less than alpha, we are rejecting the H0 of there is no difference between the mean weights. Now, this implies that there is significant difference between the weight of our respondents before they started exercise and after they started exercise. Now, this can be very, very useful in situation whereby you want to prescribe exercise for maybe another set of patients. Had it been there is no difference here, right? You can now say, let me look for another means for them to have a weight reduction. But since we can see that the exercise is very, very effective, the exercise is very, very effective. That is why we can now conclude that there is difference between their former weights and their weight now. Do we understand? I need a response, please. Can we go on? I need a response. Can we continue, please?
Yes, we are following.
So I don't know. Should we have the ANOVA today, or we should move on to? Should we quickly run the ANOVA?
Please continue. Please continue.
Because the ANOVA is quite okay. Let me quickly go through the ANOVA. We are all statisticians, and ANOVA is not new to us, especially the one-way ANOVA, which is what we are going to be doing today. The only thing that will make it a little bit long is because